use your keypad here to scroll along and down, and I'm actually going to put a spreadsheet in. So open up a spreadsheet, and I'm going to feed in just a few of the actual data piece of information, not all of them, but just a few of them. I'm going to call this first column, so in the top toolbar there, A, B here, these are going to be the column headers. So I'm going to have this as a date, and have this as time. Could call it single letter, but I like date and time. Then here I'm just going to put in some of the dates from 1912. I'll choose some at random, 1968. There's a 1999, and I'll do the 2009. In 1912, the time's 10.6. 968, Jim Hines, 9.95. 1999, 9.79. And 2009, Usain Bolt, 9.58. Notice I'm not actually looking at the months or in the days here. I'm just putting it the exact year here. I think as a first model that's absolutely fine to just put the year and not worry about the month. If you think about it, we're going from 1912 all the way to 2009. So really, what difference will just 1 or 2 months make in terms of our overall model? But we can obviously refine this later. So let's have that as a starting point. Now we're going to go to Document, and we're going to insert a data and statistics sheet, because I actually want to plot a graph of this. Okay, so now all you have to do is hover down the bottom here and click, and we're going to add the variable date here on the independent axis, and up here we're going to have time. I got to think, is that the kind of pattern you expected? And look at the way it's scaled. It's going from, I don't know, 9.55 here, 9.6. Oh, these are 0.1s, okay? So that's the scale it's chosen here. This says 1910 here up to 2010. That's fine. Some of you may have chosen to actually decide to have this as year 0 and have everything referenced from the first recorded world record. Well, the spreadsheet will let us do that quite quickly, because we might put here adjusted date. Notice when I put date here, it wants to grab this reference here. So let's put adjusted D for adjusted date. Oh, won't let me type in such a long title. So we've got a limit on the number of letters we've got in there. So adjusted means adjusted date. And then in this little toolbar here, I'm going to put in a formula equals the date. So all the numbers in here, we're going to subtract 1912 from. Can you see what's going to happen? Yep. Okay, so these now are the number of years since the first world record was set in 1912. Okay, so now I'm going to click up here to the second page. An alternative way of doing that is by going Control and left and Control and right. Okay, and now I'm going to change this variable into adjusted. Okay, now x equals 0 is our first data entry point here. Okay, there may be benefits of doing that or not. Now, once I've got this nice picture, I'm actually going to try and fit a model. So on the menu, Analyze, and we can do an add movable line ourselves. So this would be a linear model. Obviously, it's not going upwards, it's going downwards. If you just move down, we'll be able to rotate it. And you can do this by eye. Does that feel alright? Looks okay. And notice what the actual linear model says. Negative 0.01. Okay, well notice what that is. That's the rate of change of time with respect to year. Okay, so it looks like this is going down. The world record is reducing by 1/100th of a second per year. Negative 0.01. Okay, and the plus 10.6, well, that seems to be the starting world record when x equals 0 at year 0. So that kind of fits and makes sense. On here, we could possibly make a prediction of when this world record becomes 9.5. Okay. So that was just fitting a straight line by hand, but we've got more powerful tools than that. Menu, analyze, and we've got regression. Now when you want to fit a model, and a model in mathematics sense means fit a function to it, you can actually choose a linear model here. Okay, so that's the linear model that they've chosen. And notice that our best guess just by eye was pretty good. Okay, but is that really the best model to use? Because we've got a whole world of functions that we can use. So regression here. What if we chose a quadratic model? Can you see the model here, quadratic model? So there's just a little bit of more of a curve coming down here, which might be interesting. Notice the numbers here. This is 2.6 e negative 5. This is 2.62 times 10 to the power of negative 5. So this is 0.0000262. So it's a very, very small number of x squareds. Okay. I suppose that helps us give us this nice spread out shape for the quadratic. So is quadratic a good model for it? It looks like it fits the limited data we've got. But what if we go to menu and we go to window zoom, and what if we just go to window settings now, and on the X we're going to just increase this now to 200 years after 1912. So that takes us to 2112. Let's have a little look. Okay, so maybe the model does still fit and still holds up quite well. Yeah. And what if we take the menu here, go to window zoom, go to window settings, and now change the Y values. So let's go down to our goal of 9 seconds. I'll take it to 8.9 seconds. Okay, so this is 9 seconds here. Is our quadratic model still a good fit? Is our linear model a good fit? And if we try one more, menu, analyze, regression, and what about an exponential? An exponential model is quite interesting. Okay, so you've got a choice of functions to use, and based on these functions it'll be interesting to see when 9 seconds is actually hit.